you're welcome to this panel. Hello. You're welcome to this panel discussion, which we're holding on performance measuring tools for the cloud. It's going to be a panel discussion. We are going to whiz through some slides, about 4 presentations, and we'll go through them very quick just to level set. And then after that, we should have enough time to have interactions and answer questions from the audience, and also share experiences from you guys. So basically, we'll be looking at the kind of tools that we use in measuring the cloud. I'm just going to introduce to you the panelists and presenters for this session. Douglas Shakshoba, commonly known as Shaks. He's from Red Hat. And then we have Mr. Wang. His first name is a little bit difficult for me, but he's from AW Cloud out of Beijing in China. And then you have Mr. Yuting Wu, who is also from AW Cloud in China. And then we have Mr. Das Kamhut, who is from Intel. And Nicholas Wakou, you are the moderator for this session, and I work for Dell. Now, we are not going to go through any further introductions, just in the interest of time. But if you go to the OpenStack website on speakers, you'll get the details of who these panelists are and what they're doing. The agenda, again, we are going to be looking at Rally and Cloud Bench, and that will be, Shaks will be presenting that. And then we shall also look at Rally and Dichotomy, and that will be Mr. Wu. And then performance analysis by HA Proxy, which will be done by Mr. Wang, and then industry standard benchmarks that we'll present. Without much ado, I call upon Mr. Shaks to actually kick off the presentation.
Great. Hi, good afternoon, everyone. Thanks a lot for joining us. So let's go through this rather quickly, as Nicholas said. So our team, I'm the Director of Performance Engineering at Red Hat. And if you've been using OpenStack and trying to measure performance in general, there's a lot of everything we do at Red Hat is open source. So as we work with communities, Rally is the first one. Share some quick, brief roll through a couple of examples. CloudBench is another effort that all of these, again, you can download, go to the URLs, pull the benchmarks down, and it's really important sometimes to measure these. So I'm going to concentrate on the first 2, but we do participate in industry standard workloads that Nicholas is going to cover as well. Real important: SpecVirt, SpecCloud, TPC, TPC Virt. There's special tools for whether it's Cinder or more recently the PerfKit tool set that Google open sourced. We're real happy to see that now that has an OpenStack plugin, and we can use that with OpenStack. And so anyway, next slide. Or would you like me to? Cool. So again, one of the things Rally is very useful for, so in performance engineering, we really want to run at the speed of your hardware. So you configure a system, you configure controller nodes with networks, with disk and storage. A lot of people say, hey, put it all together, and I only have single drives in each of the servers, and I'm wondered why my provisioning is still taking a long time. Rally actually allows you to do, here's an example of, doing automation of provisioning, and it'll provision the essentially the VMs and come back with a success failure. And failures usually means it just the VM didn't respond in a certain amount of time necessary on your given server. So if you run this yourself, this is very important to help you size your own clouds to figure out how fast you can burst provisioning out to your clouds. And if you guys want to see this, my team, Talarico and Alex and others, essentially have papers on how to use Rally. So the cons for Rally is it's hard to synchronize benchmarks together. So it will automatically provision and run a workload, but if you're doing, like in this case, 24,000 VMs, right? Not all of them are going to log in at the same time, so they're not necessarily all running concurrently. So, next slide. So, and so here's an example of running a CPU workload, and as you over-provision the number of VMs, you start seeing that, in fact, the average response time or the average throughput of the application drops. That's expected, and then if you continue to provision, you can actually run the servers on your cloud out of memory, and so it actually gives you OMM kills. Next slide. So another example with CloudBench, we actually were able to, CloudBench actually helps you orchestrate the workload so that you have it basically has all the VMs check in, and it allows you to put a workload. In this case, it's NetPerf, but there's actually several other examples. You can take your benchmarks or workloads and actually embed them into CloudBench fairly easily. It's a bit of a difficult harness to use. It's out there. You can download it, but it allows you to then run multiple networks. In this case, 3 different packet sizes on the right-hand side, and essentially the sum of, you can do things like VXLAN offloads and measure the effects or other hardware accelerations. Second tool that came out, I think, originally from Mirantis, in fact, was the Shaker tool that also does a great job at automating network performance. And my final slide is here on disk I/O. So cover CPU, memory, network, and I/O. So those are the 4 fundamental performance food groups, if you will. And so here's another example of putting FIO in a harness. Joe Tallarico did this, and essentially measuring the difference between ephemeral storage and a Ceph tier that had dedicated storage across and so the average number of IOPS per VM, you can see it's a lot different running ephemeral versus a storage tier. Okay, thanks.
Thank you very much, Shaks. The next presentation will be from Mr. Wang using Rally and dichotomy.
Good afternoon, everyone. There are 3 points I would like to share with everyone. This one is what Rally 2 can do. The second, the Rally and the dichotomy, and how to the Rally 2 in the Arc2 project. Firstly, what the Rally can do. Rally is a benchmarking tool that automates and notifies middle nodes OpenStack development, cloud verification, benchmarking, and profiling. Many companies will use the tools. For example, Mirantis, IBM, and Cisco, Huawei, AWS Cloud, and so on. Rally can help us do automation tests and CI with Jenkins, and also help us do cloud verification and profiling the cloud environment. When we need the OpenStack environment for debug the code, in most cases we will use a Rally that developed to the DV stack. Secondly, the Rally and the dichotomy. When using the Rally to do performance testing, in most cases, often need to try a lot of time to find the performance bottlenecks. For example, a single Nova API handle A single Nova API can handle withstand the number of concurrent create instances. The dichotomy is quickly help us find the performance bottlenecks. How to use it? We can see the demo. Firstly, you can need to set a master value, handles. Take the middle value 50. Then, if the test results that successfully in intermediate value between 50 and 100 is 75. Advisor intermediate the value between 0 and 50 is 25. Using the dichotomy by analogy until find the performance bottlenecks. Lastly, how to apply the rally in active projects. The rally tool is used a variety of the ways. For example, CAI with Jenkins production of cloud. In our business environments, that's all component working in the HA proxy. The NOAA can respond to 1,000 concurrent to create instance. This is of test result. For HA proxy and curriculum testing, welcome my colleague Wu Yuting share with everyone. Thank you.
Thank you. Performance analysis, HA proxy, using AW Cloud.
Good afternoon, everyone. What I will introduce is using HA proxy to analyze OpenStack performance. HA proxy is a free open source software that is usually used to provide high availability load balance or proxy server for TCP and HTTP load server applications. So in an OpenStack development environment, we usually the common practice is use HA proxy to provide load balance for each OpenStack API services. You can get this from the slide, and in addition we use Cpu to provide high availability for HA proxy. And since HA proxy is located between users and servers, so HA proxy knows everything about the request. So we can, if you enable the login on HA proxy, you can get more information about the request. So by analyzing the login, we can get much information about the server, and we can analyze the performance bottleneck about your services. Okay, I will show you an example. Okay, the upper. Okay, the upper part of this slide is the HA proxy log line. There are many fields, but we only need to focus on several fields. First, we need to focus on is the ATS field. There are field numbers in this field. They represent the response time of your request at each stage. First you need to focus on is the TR. It means the connection. It means it's the time in milliseconds that present the time that waiting for the server to return a full HTTP response. And TT means the time in milliseconds that the server accept and between server accept and the last close. So if false, this value is too high, high value, that means that there may be performance of your service, and that may be a bottleneck of your service. Next slide. Okay. The next you should focus on is the settings field. There are few numbers in this field. We should focus on is FC, EN, and SRN, CON. These fields represent the connections all your connections of the servers when this session was logged. FECON means concurrent connections of the front end, and SRVCON means total concurrent connections of your service. Many services has a max connection configuration parameters. If this value is close to or equal to the max connections, that means that your service is overloaded, and that may be a performance of your that will be a performance problem with your services. So from that's all. From this you can. So what I want to say is that you can analyze the HA proxy to know the performance problem of your services. That's all.
Hello. Thank you. All right. Thank you very much, Mr. Yuting. Sorry, I'm going the wrong way. All right. The next and final presentation is going to be on industry standard benchmarks. And I'll make it whiz through it very fast. And one of the reasons why that's going to happen is because tomorrow we are going to have, me and Doug are going to have a more detailed session at the Dell, one of the Dell breakout sessions tomorrow, where we will go into more detail and more fun. But nevertheless, industry standard benchmarks define standards that are used to measure and compare computer systems and solutions. Oops, keep going the wrong way. Now, there are two major performance consortia. There are several others, but the ones that we are going to focus on today is SPEC and TPC. Between the two, they have a membership that is literally the who is who within the computer industry. The one standard that is coming out and that is going to be specific to measuring the cloud is actually coming out of the SPEC organization. It's called SPEC Cloud. It's an IAS benchmark standard. This committee, the SPEC Cloud has a committee that has been in place for about 3 years. Today, we are actually lucky that one of the current chair of the SPEC Cloud committee, Salman Bassey, is here. Salman, if you can. He literally did most of the developing and coding of this benchmark standard. And actually, I don't know that Joe Talerico is around. He works with Shaq. They did a lot of work in developing this benchmark standard. Now, what it does is that it measures the performance of an infrastructure as a service cloud. It measures both the control and data plane. It uses workloads that you could look at and say they are realistic, mainly used in the cloud, and it produces the kind of the kind of metrics that you would expect for the cloud, and those which actually can be used for comparisons. This slide is a very high-level view of the pieces that make up this benchmark. On the left-hand side, you have the benchmark harness. The harness has got drivers and a report generator. These drivers initiate the creation of instances on the cloud under test. The cloud under test is what you see on the right-hand side. What they also do, they have drivers that create workloads which test the cloud. There are two workloads that are being used in this benchmark. There is K-means on Hadoop, and there is YCSB. Those two workloads are used in the two benchmark phases of this benchmark. The two benchmark phases, there's a baseline phase, where these workloads are run separately and individually, and then there's the elasticity phase, where these workloads are actually run simultaneously, and the drivers keep adding more and more workloads until the benchmark stops due to some conditions. When the benchmark stops and ends, there's a report generator which captures the performance metrics and generates a report. Now, this benchmark has got a notion of testing configurations. There is what they call a white box cloud. A white box cloud is actually one where the tester is in full control of the cloud under test. They know what is under the hood, and they can define it to a specific level. That is what you would commonly find in private clouds. Then there is a black box configuration, which is what you would typically find in public clouds. And in this case, the user or the tester does not have knowledge or control of the underlying reference architecture. What they normally have is actually just the building information. The two workloads that we're talking about, we have YCSB. That was mainly introduced because it simulates social media. And what runs in the background is the database is actually is Cassandra. And then there's K-means, which runs on Hadoop, very CPU intensive, and the committee chose Intel High Bench for various reasons. So what is measured? Basically, this benchmark measures the number of AIs that can be loaded onto a cluster before SLA violations occur. It measures the scalability and the elasticity of the cloud under test. It is not a measure of instance density. There is several other benchmarks in spec and in the TPC that can do that very well for you. This particular benchmark is devoted mainly on scalability and elasticity. But these individual workloads can actually be used to stress the cloud under test. If that's what you want to do, you can use K-means to stress your CPU and memory, and you can use YCSB to actually generate enough I/O to stress the I/O and the network. So, like I said, at the end of every elasticity test, you have a report. And that report literally gives you the primary metrics. The primary metrics of this benchmark are the ones that are actually in yellow. You have scalability and the number of instances at which you are measuring that scalability score. And then you have elasticity. And then you have the mean instance provisioning time. Then there are secondary matrices that also displayed in the little box on the right. And like I said, tomorrow at the Dell breakout session, we'll go into more details of what all these numbers really mean. So, but for now, this was really meant to be an interactive session. And without much ado, we'll request for questions, comments from the audience. What you do is capture my eye. If I can see you, I'll get you the opportunity. You can ask a question, which will be answered by members on the panel, or the answer could also come from the audience. So for the next remaining minutes before lunch, who is taking the first shot? We need some.
So Thanks. So the challenge out to you folks is, again, these are open standards. So more and more we're looking for other ways to, so the last two are industry standard workloads. Those should level the playing field. There is a review process by the consortia to make sure that the benchmarks were conducted fairly and accurately, and in fact, the vendors police themselves. In some metrics, the TPC actually has price values in it, but the other open source projects, more and more we're seeing vendors like Intel recently shared their public cloud, I guess their Intel Rackspace offer sign-up. So since maybe Das can comment about the Rackspace Intel effort. I don't know.
Actually, maybe we just start with a question. Do any of you guys have performance issues in your OpenStack environments? Everybody's is perfectly fast. Okay, so who doesn't? That's a good way to start. All right, let's go to the question over there.
Okay, so confirming, so the most of those benchmarks, like the TPC one, we can publish in a kind of a peer review type of approach, unlike like VMmark, which you couldn't really publicly state. Is that correct?
I think it's on, but it's not on. It's just quiet. Oh, there we go. Yeah. So again, feel free. Individuals can. You have to join the consortium, or you can actually. There is a fee to download the benchmarks. You can run them privately. In fact, we use the industry standard benchmarks to sort of beat up our regular operating system, our Rev, and OpenStack now more and more. So the consortiums, we're trying to build a standard that, vendors can actually publish against. So Red Hat, Dell, I think everyone here on the panel, we're not about trying to make a proprietary benchmark.
And I think what we should start seeing, since it's an open source community, is everybody sharing. So we didn't talk about Google PerfKit much, but the whole purpose of Google PerfKit is to expose the reality of everybody's running clouds. And it's not about like standing up a fake synthetic cloud. It's actually about taking workloads that we all run today and hitting against a running production cloud. Or if you can create a synthetic running production cloud, that's pretty important. But the expectation we would like to see is everybody sharing publicly. What's the good of benchmarks if people aren't sharing? And like everybody said they have a performance problem, but like who's actually partnering together to fix it?
And a follow-up to that, is there anything that actually tests higher level things like Cloud Foundry or Docker type of workloads?
Well, most of those benchmarks aren't designed for Cloud Foundry. Cloud Foundry has various tests. PerfKit is designed to test container workloads as well as FIO, as well as Cassandra and various things. So you'll see plenty of other tests happening. It's just, what are you testing? Like startup of something, or are you actually testing a workload?
Well, I mainly wanted to see if I want a repeatable process so that I can make sure that if I change something in the lower systems, that I have a known number in my Cloud Foundry or my Docker type workloads. So I know that if I'm doing 100 of these units per second, or whatever that number is, and I make a change from like EMC to NetApps or someone else's storage, or I go Scale IO, or I go Cisco switches, I can make sure that that didn't negatively impact that number. Is what I want to be able to share. That way I can prove to my customers, which are my business units, that we are actually improving the system when we actually have a known value that we're actually comparing against.
Right. And so I think that's really important to be able to do that. I think the Rally and Intel's High Bench and Cloud Bench are out there to give you a kickstart to do that for free. I think PerfKit has advanced. Really excited to see at the beginning of the year, PerfKit will essentially build a harness for you. It does support OpenStack now, and you can select the benchmarks you want. If you can run spec, for instance, in PerfKit, you still need to get a spec license for that workload. So you kind of have to build your own. I gave you a couple examples of CPU memory, network, and I/O, but kind of build your own little regression kit, and also some of the Rally examples that these folks had. It's not just running the load, but you can inject problems. HA proxy, you can debug the problems. So we're not going to be getting into monitoring, and that's a huge field. There's lots of talks on that. But we are looking for, are we getting it right? Can we hop on? We recently did essentially not rent, but we borrow, Intel Rackspace, 132 nodes, scaled up things, and there's a sign up. So contact Intel on that.
Yeah, so quickly on that, we actually, Intel is funded 2 1,000 node clusters that are designed for scalability testing. Obviously, it's not going to solve your problem, but we can talk about your problem a little bit more. But basically, anybody that's pushing upstream code, moving it forward for performance and scalability, you can sign up to the governance process. Red Hat did a run through. There's a bunch of people doing runs through. But basically, how do you really prove scaling? But to go back to how do you test that changes aren't affecting your performance, I'd highly suggest that people use like a CI/CD process for your infrastructure. Hopefully you have a non-prod space that looks somewhat like your prod. But even when you go into prod, I mean, why not do A/B testing? But you can run something like perfgit, you run spec, you can run that and actually see what was the change. Did it have a functional change as well as a performance change? But that should be pretty standard practice for running a cloud to see what's going on in reality.
Yeah, the reason why I wanted an independent one was to make sure that my applications over time will change. So I can't use last year's number to compare this year's number. So I wanted an independent workload that I could generate, and I could compare those numbers, unlike VMware, where I couldn't legally compare my numbers to another company's numbers to see if I'm doing something right or wrong as far as the way we built something.
Yeah. So I just encourage, maybe Cloud Foundry folks to pick up some of these industry standards, share the loads, independently check. So publishing is, each vendor has their own little rules on that, and so you'll see Red Hat, we're pretty much open, so we don't have EULAs that prevent you from publishing and things like that. So not mentioning any names, but other people do have EULAs that don't allow us to publish benchmarks against us. Anyway, so I'm not, I do think it's important for regression testing. I think each vendor's software should be reasonably regression tested. And in these CI environments, in fact, there's some additional tools we hope to open source that we're developing that kind of wrap some of these tools into more of a CI automated way of every time there's a release, not just for our own testing, but we'll open source that. So you'll be able to pick that up in the future.
Okay, do we have any other questions? Comments? Experiences?
Okay, so everybody said they're having performance problems. Does anybody want to just call out how big are your clusters getting when you start running into performance problems? And if you were to pick one thing for the community to fix, what would it be? Anyone? No one? You guys love it? Performance is perfect.
That's fairly cool because, another whole dimension. So we shared some data plane level stuff, but measuring the control plane of OpenStack, I think that's kind of what Rally and some of the other efforts that are built into tools and actually now ship. It's a full project, Rally, for instance. But putting pressure back on, the control systems and actually making sure vendors configure the control plane properly, for 10 gig networks, and don't just give it the same. Your compute tier might be this tiny, but smaller nodes, and essentially how big do you want to make these others? So again, we have a few papers on that, on how to use these tools. Happy to share that with everyone. But it's also important to try to force errors and problems. I don't know if you guys have experiences you want to share from your cloud test.
They use Rally a lot.
Yeah. Okay, guys. I think we are almost there. And yes, Salman.
Thank you. So I guess one particular problem that almost everybody is running into is as they scale, OpenStack has, thousands of configurations. You do permutations, this is probably in gazillions. You configure some hardware, you don't know how it works. So it will be very useful to have hardware configurations and OpenStack configurations that can be certified to say they run at this much scale, where scale is defined at a certain level. I think that's something that's not quite there. I think Intel's big cluster is a step in this direction, but we need to have this kind of configurations, hardware certified at scale, so that somebody, there was a talk earlier by Volkswagen who was setting up a big cluster. They ought to be just able to buy the right hardware which is certified, fix the configurations and be ready to go, rather than doing their performance testing on their own. So I think something to think about as we go towards scale and perhaps for the next OpenStack summits.
Yeah, so the purpose of those 2,000 node clusters is to expose everything that we do. Anybody that goes into it, they have to commit to share all their results. That includes configurations too. So basically what we'll start seeing is more reality. Like I've heard some people say they run 1,000 node compute clusters with OpenStack. I don't believe them because it probably doesn't actually run anything, or it's like actually all a bunch of regions. So the whole purpose of these clusters is to really show reality. If you come in, do a 200 node cluster test, we want you to show the scalability. How did you pull it off? What's the configurations that you did? And it should make it a lot easier. We're not actually doing certifications. That's much more complicated and like legal problems, but fundamentally open up what's actually happening and what these tests show.
Yes, Arkady?
Arkady.
Hello. Quick question. So right now you pointed out various different benchmark on both infrastructure of the OpenStack itself as well as application. So what happens when both infrastructure as well as applications start moving from the virtual machines to the containers? What do you expect will start happening with the benchmarking methodology to accommodate that?
Well, I'll give a quick first perspective, but feel free to join us, Salman. Absolutely, we hope we've designed the benchmarks so that they're almost neutral. Most of these benchmarks we're running are actually bare metal benchmarks in the first place. And so as a benchmark team, we're constantly running bare metal. 4 or 5 years ago, everything we ran all various applications, much deeper suite of applications than shared here, databases and stock exchange loads, et cetera. We run them bare metal and then virtualized with KVM. And then now we run them, the past 2 years, we've been running on atomic containers. So shouldn't require any major surgery, especially if you're running containers in an OpenStack cloud or a OpenShift on OpenStack or whatever container technology you're going to do. We hope there's very little or no change. So if you invest in some of this upfront or back into your own private cloud area, hopefully you have an investment that you can move forward. And the Cloud Foundry example, for instance, we believe if they have, we're trying to run these agnostic to the implementation.
Yeah, one change we've seen though is if you do performance TCO with virtual machine units, obviously when you switch to containers and bare metal, you have to rethink what's your normalized unit. So a lot of people will do analysis and say this many virtual CPUs equates to this amount of performance and this much TCO. Once you switch to bare metal, that changes. So that's one thing, but that's okay. That's just a new math problem. And then the second one is you'll definitely see a difference in I/O because when you go bare metal, you have a little less I/O issues that the hypervisor introduces.
Okay. Yeah.
I will just add that from the perspective of Spec Cloud IS 2016 benchmark, there is no restriction on the type of instance. So for example, the instance can be a bare metal, a virtual machine, or a container. And it's up to the cloud provider to test which one to use, and then you can measure the results and compare the difference. So that's exactly to address that point.
Okay. Anyone with the last question so that we can complete right on the dot of time?
I think it actually is lunchtime, so we can just say thanks.
All right, thanks. Thanks for coming. And again, tomorrow from 2, I think probably in the same room, we are going to go into more detail on the Spec Cloud benchmark. Thank you, guys.